So, hello guys. So today we will visualize and see what is the extent of the flood in the areas of the Valencia, Spain. How we can visualize to the satellite images. So what is the pre-flood scenario and the post-flood scenario, and we will also compare our results with the European Space Agency data. We will also learn about what is the importance of SAR data, what is active remote sensing, and how the different products of the Sentinel is used in the different situations. So let's start with our region of interest. So search in the data, search in the places Valencia, Spain. So it will zoom into our region of interest. So switch into satellite mode. Okay. So we all know this is the place where uh, the flooding has occurred. So create a region of interest. So you can use add a marker button, or create a polygon, or draw a polygon, or a rectangle. So I am selecting the exact region where the flood has occurred, so it helps in the visualization and the detection of the flood areas. So after drawing the rectangle, you can edit the settings from geometry to feature collection. So if it is geometry also, there will be no error, but for my convenience I am converting into a feature collection. So this has been a regular practice now. You should know how to create a region of interest in your uh, Google Earth engine. So here you can see my region of interest has been loaded. Now uncheck the geometry. So first we will try to visualize through the Sentinel optical data. Sentinel, let's search the Sentinel. So there are two data sets for the optical remote sensing: Sentinel-2 multispectral instrument level 1C and 2A. So what the difference between the two data set is that the level 1C is launched much earlier at phase of 2015, but the radiometric corrections and the scale have been not been adjusted in the Sentinel 1C images. In the 2A, it has been radiometrically corrected, and it is ready to use data. So yeah, here you can see there is no scale is given. So let's import our Sentinel-2 data, name it as S2. Okay. So now let's create an variable. We will have two images, one before the flooding and one after the flooding. So first variable will be before. Let's create an variable before, and select our Sentinel-2 image. Okay. And filter the date. Before filtering the date, let's filter the bounds to RY, and filter to date. So we all know that the flood occurred on the 30th October and 31st of October. So any date which is prior to the 30th October will be our pre-flood scenario. So let's select 2024 October, say 10 to 2024 October 25. Okay, then we should also uh, print this and see what's there, how many image collections are available in between these filters. So it's loading now. So we have the 9 elements. uh, let's filter our cloud cover also. So filter metadata, filtering cloud pixel percentage, because we want a clean scenario. So give the arguments the cloud cover per pixel percentage should be less than, say, 1%. So next, let's run again. So here you can see the 0 elements can be seen. So no worries, let's remove this cloud cover percentage, and or else we can increase the cloud cover percentage filter to, say, around 5%. Since the data range is uh, date range is less, we are not getting this much of cloud free data set. So again you can see now, yeah, one element is there. So let's select that first and clip to our region of interest. I missed the P. Okay, so that's it. So next add this layer to map, leave the visualization functions default, and name it as before flood or pre-flood, you can say anything. So now our layer is loading. Oh, okay, now the data set is not uh, visible, only one line is seen. So let's remove this cloud cover only and take a mosaic of the function. Take a mosaic of those elements, those 9 elements which are present in there. So now again our layer is loading. Yeah, yeah. So for our region of interest, the cloud has loaded, but we have more cloud. So yeah, so this is the difficulty we are facing in the Sentinel-2 image. So if you apply for the post image also, post flooding image also, you will get the similar results. So this is one of the limitations for our Sentinel optical remote sensing data. So I will show you for the post flooding data also, like for example from 29th of October to say 1st November. Again the cloud cover will be more. Yeah, here you see both the images have been filled with the cloud because the rain is more, and so here you should have after. This should be also after, after flood. So let's visualize them with the true color compositor for more information on this. So just the reflectance range to 100%. So similar case with our after flood image also. So stretch the reflectance range to 100%. Yeah, so you can see the cloud cover, we cannot filter it out. The satellite data is not available for getting the cloud free data set. So in order to overcome this limitation, we are going to use our SAR data, the Sentinel-1 GRD, that is uh, ground range detected data. It using the C band. So the SAR technique, as you all know, it's an active remote sensing technique. It is using an microwave based remote sensing. So it has 4 bands for VV, HH, VV plus VH for single polarization and the dual polarization. So most of the uh, processes or the analysis has been done using the same polarization techniques, VV or VH, and we have the 4 bands as I've already told you. So let's import this SAR dataset and see what the difference between our optical data and the SAR data. So an active remote sensing image, an active remote sensing technique is that it does not rely on any kind of the sunlight. It uses its own source of illumination, and also it can penetrate through the clouds. That's one of the advantage of this Sentinel-1 data. So let's clear this out. Let's create a separate variable now. So Sentinel, for the Sentinel-1 data, say pre-flood. So select our S1 data, that is the SAR image, ground ridge detected image, and filter them by bounds. To the our region of interest, and also filter it by date, say 2024. So it should be a string, sorry, 2024 October, say 1 to 2024 October 8. Okay. And in addition to this, we should also have some additional filters for the SAR data. Let's start this with the dot filter function, and we are using e dot filter list contains function in order to filter our transmit polarization technique. So you open our SAR data, come to the image properties. So if you can scroll down, you will search for transmitter receive polarization property. Yeah, so here you can see the transmitter receive polarization. It's a list of strings, so it has the four variables VV, VH. So we are mainly using the VV transmit polarization technique for this particular analysis. And we should also filter one more property, that's called we are using the equal functions here. And open the image properties. Now we should search for our orbit pass image, or before orbit pass image we should search for our instrument mode. So it is a string, so we mainly use the interferometric wide swath path for our instrument mode. For the VV band, so select the instrument mode, it should be IW, interferometric wide swath band. And we should also apply one more filter using the equals function for our orbit pass mode. So open again the Sentinel-1 data, search in for orbit properties pass. Yeah, so it's again a string, so it shows the direction of the orbit, either as a ascending or a descending for the oldest image data in the project. So we use the ascending data here, so give the argument ascending. Okay, and after all this we should select our band, that's our VV band. So in this band, it's the vertical transmission is done, and the receiving type is also vertical only. So if you select the VH band, where the uh, these electromagnetic radiations have been transferred vertically first, and the receiving will be in the horizontal mode for the VH band. So we will be using our VV mode, and let's print this. So let's see how much image collection we have for this particular filters. So yeah, we have three elements, so you can use the mosaic function now in order to have the mosaic of these data sets. Okay, then clip it over region of interest, you run. Yeah, so it has consist of only one band. So let's add this to our map to see whether cloud cover is there or not. So leave the visualization parameters empty, and rename it as a pre-flood image. Run. So yeah, some error we are getting. Yeah, we should not use the flower brackets, we should use the square brackets for the star data. So stretch to 100% and apply. Yeah, so clearly you can see there is a no cloud cover in our pre-image. So whatever the dark areas having the low reflectance, there is an absorption of more amount of electromagnetic radiation, and the gray color and the white color is indicating that there is a high amount of reflectance. So this is SAR data is particularly uh, more sensitive to roughness of the surface. So the water bodies, as we can see, there is a no much roughness, or the texture alignment can be seen. So it is having the low amount of reflectance. So If you want, you can add the colors in order to visualize them better. So let's use a three color palette. Say for the low reflectance, let's have the blue because it's a water, and leave white for the neutral values, and let's say red for the non water body areas, and click on the apply. Yeah, so clearly you can see the water bodies are visible in the blue color. So let's import this visualization function and rename it as viz, stands for visualization, and you can rename it as viz now. So if you give run at a total once, you will get this image. So now it's time to create our post flood scenario image using the SAR data. So simply copy our previous function script, and just rename the pre-flood as post flood, and we should also change our date range because since we know, here you can see the European Space Agency uh, data. This is the before flood data. 30th October is the flooded day, and the 8th October is our uh, before flood day. So let's filter it to say 29 and November 1st. Okay, so rest all filters remains the same. So now to check the date, we will remove this, and we'll print our post flood the data in order to check what's the date of our image. So post flood, so click on the run now. Yeah, one element is there. Directly go to the properties. Here you can see the images of 2024 October 31. So this is the day after the flood which has occurred. So it's okay to use this data. So let's remove this print file again. So we are using again the mosaic function can be used, or the first function can be used. So let's use mosaic only, and let's clip our dataset to region of interest, and it should be post flood visualization. Pre should be renamed as post now. So click on that. So yeah, our two layers are loading now. So yeah, stretch our range from custom to 100% and click on the apply. Yeah, so clearly in this image we can see the water body extent. So how the flood has affected the agricultural lands and the urban lands which are near to the wetland. So if you can just slide down the post flood, so here you can see a clean patch, and if you can increase the post flood, the water area has been extended. So this is the one of the main advantage of using the SAR data, the cloud free data, which is provided by the Sentinel-1. So if you want, you can export this to your Google Drive and use it in the other functions also. So if you don't want any visualization parameters, you can set it to grayscale. So this is the European Space Agency's data set. So this is the pre-flood scenarios, and this is the post-flood scenario. So you can see this data set has been derived from the Landsat 8 image, but we are using the SAR data. It is more or less in align with the European Space Agency's data. So that's it guys for today. You can export this if you want, and you can visualize in the other GIS software such as the QGIS or ArcMap. So if you have any kind of doubts, you can post it in the comment section. Thank you very much for watching.